3.6 Simultaneous Inequalities. So this is very similar to what we have been doing, except for now we're working with inequalities as opposed to equations. You'll notice we have two inequalities here, and you can have more than that. And we are not looking for necessarily an overlapping point. We are looking for an overlapping region, because remember, when you graph inequalities, you actually are doing a lot of shading. So you're going to see in a minute what this looks like. But your answer, there are going to be infinite answers that will work. But basically, the x and the y's that I come up with both have to make both of these inequalities true. Okay, so the only way to do a simultaneous, or to solve a simultaneous inequality, would be to use graphing method, because if I go to use substitution, I can't substitute anything that's greater than. I can only substitute if I had y equals x plus 3. And then I could take the x plus 3 and substitute it in for y because they were equal. But in this case, I can't use substitution because nothing's equal. Exactly. This one's less than or equal to. This one's just greater than. Elimination won't work either because the signs are not the same. So you couldn't just add these two together because you're not dealing with two equal equations. So our only choice here is to graph and to make a visual representation of our solution set. So what that involves is remembering how you graphed inequalities in Coconuts and Crocodiles 2.4, I believe. So the first thing you need to do is you need to think about what is my slope and what is my intercept. So I want to be thinking about the equation y equals x plus 3. And what is the slope here? It's 1. And what is the y-intercept here? It's 3. So I'm basically going to find 3 on the y-axis, and then I'm going to use a slope of 1, and I'm going to graph it. The next thing I have to remember is this going to be a dotted line, or is this going to be a solid line? And because it's greater than, it's going to be a dotted line. Okay? And the third part to remember is the shading. Is the shading above or below? We're going to have to think about that once it's in graph form. Looking at the other one, this is already in its y form. So y equals negative 2x plus 9. Our slope in this case is negative 2, and our y-intercept in this case is 9. Okay? Because it's less than or equal to, when it's less than or equal to, I'm going to have a solid line. Okay, so dotted line, solid line. I'm going to represent this one in red and this one in black. Okay, you'll be happy because I already did the graphing for you. And here we go. So if I look at my red equation, I have my y-intercept at 3, and I'm going up 1, over 1, up 1, over 1, up 1, over 1, up 1, over. And they do have a point of intersection, but the thing I haven't taken care of here is the shading. So if I'm looking at my dotted red line, and I know y is greater than x plus 3, this line represents x plus 3. So if y is greater than, I'm going to come back to the y-axis and say, where is y bigger? And it's going to be on this side of the line. So that would mean I would do my shading on this side of the line. Okay? Now, if I look at the other one in black, our y-intercept was at 9, which was up here, and then we were going down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Looks like my line got a little bit off. And we needed a solid line, as we said, and now y is less than or equal to this equation. So if I come to the y point right here, where are my y values less than? Oh, on this side. So I'm now going to do my shading on this. Okay. And my solution set is going to be found at the cross-hatched region. Does anyone know what cross-hatched means? Well, cross-hatched region would be basically where you have basically shaded two different directions. They call that cross-hatched. The nice part about our graph is that I use two colors, so where it's the black and red region. So I'm actually going to erase the other regions just so I can see my solution set nice and clearly. On your papers, you can leave all the shading and then just kind of try to do an extra highlight on where your solution set is. So it's really clear to see that my solution set is in that region right there. Okay, so that means that any point in this region is a solution to both of these inequalities. So just to do a check step, I'm going to pull a point out of there. So let's pick this point right here. That happens to be negative 1, 2, 3, 4. So that happens to be negative 4, comma, 1, 2, 3, 3. Okay, so I can pick anything out of that region. Now let's test it in both our inequalities. I have y is greater than x plus 3. My y value is 3 is greater than negative 4 plus 3. Negative 4 plus 3 is negative 1. Is 3 greater than 1? Yes, indeed, that works. But it has to also work in the other equation. Y is less than or equal to negative 2x plus 9. Y in this case is 3 is less than or equal to negative 2 times negative 4 plus 9. Negative 2 times negative 4 is 8 plus 9. 8 plus 9 is 17. Is 3 less than or equal to 17? And it is. So I'm pretty sure I got the solution set right. And the only way to show your solution set is by shading, and that's clearly the correct answer there. You could choose several points if you were nervous that you got the wrong answer and keep testing them to make sure. Okay, let's do one more. Now this is probably as hard as I can get it, and it's going to test your memory of the little tricky rule about inequalities that we have to remember. So let's start with the first one. I can't graph this one until I transform it into y equals form, or y is less than or equal to, or y is greater than or equal to form. Basically, y has to be by itself. So I'm going to need to divide by negative 2 all the way across. But hopefully a bell went off in your head, because when you divide by a negative number with an inequality, do you remember what happens? The sign turns. So the sign went from less than to greater than or equal to. Okay, so now I have y is greater than or equal to negative 3 halves x plus 2. So a lot of negative stuff going on there. Okay, now my y-intercept is going to be at 2, my slope is going to be negative 3 over 2, and we're going to do some shading. First, I'm going to transform this equation. This one, I'm going to leave y where it is, and I'm going to subtract x, and I'm going to get y is greater than negative x minus 1. Notice the sign didn't switch. I did subtract a number, which is kind of like using a negative, but because I didn't divide or multiply by a negative, the sign just stays put. My y-intercept is at negative 1, my slope is at negative 1, and so now I'm ready to graph the two lines. Okay, so I've done them both for you here. The red line corresponds to the red. It should be, oh, the red line's not right, so let's adjust it. If I grab the red line, it should have a y-intercept of negative 1. It'd be much easier if it was positive 1, wouldn't it? And the slope is at negative 1, which is fine. There we go. Right there, roughly. And if I were going to do my shading, I would have, let's get that off, okay. Y is greater than, so I'm basically going to be doing, go to my y at my y-intercept, and I'm going to say where the value is greater than, so it's going to be on this side of my line, and it's dotted. Okay, and then if I do my y, my other equation, it should be at positive 2, which look at that. That one is incorrect also, so maybe I was just testing myself. That one goes through at positive 2, and the slope should be at negative 3 over 2. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So it's not perfect, but it's pretty close, something like that. Now, if I were going to do my shading, it's going to be greater than or equal to. So we already know it's solid. I go to my y-axis and I want to be greater than. So that's going to be on this side. Okay, well, it doesn't look so cross-hatched anymore, does it? But if I use an eraser, I can start to figure out, okay, let me use a small eraser, that this is not overlapping. That looked like it was, but it was just a sloppy maneuver here. Now, if I erase kind of all the way up to there, you'll see that the cross-hatched region, or the shared region, is going to be this region over here on this side of both lines. Okay, and if I were going to pick a point, let's pick an easy point, maybe something that's right here. The point in there corresponds to both the red and the black area, and that is 1, 2, 1. 2, 1. So it needs to work in both equations. So if I take my first inequality, I have 2 times y is less than or equal to 3 times 2 plus -4 or -4. I get -2 is less than or equal to 6 minus 4. I have -2 is less than or equal to +2. Is that correct? Is -2 less than or equal to +2? Indeed it is. And now if I plug that into my second equation, x plus y is greater than -1. I have x is 2 plus y is 1 is greater than -1. 2 plus 1 is 3. Is 3 greater than -1? Indeed it is. So my region on this side, which now I'll even highlight in yellow, everything over here is going to satisfy both inequalities and therefore be the solution set. Okay? So use colors if you want on your homework, or you can just use a pencil and cross-hatching, whichever works best for you. Good luck.